So we're going to finish up our discussion on Chapter 6, Normal Distribution, with 6.3, working with normally distributed variables. This is basically putting everything we've talked about in sections 1 and 2 together and plugging in some numbers and doing some calculations. And, here's where we get to do some of the fun math stuff, right? Okay. So when you're doing one of these problems, it's a good idea first sketch the normal curve and shade the region of interest. This kind of helps us do a kind of a ballpark estimate when we get our answer. Say, does this look reasonable or did I mess up? Because it's really easy to mess up when we're doing this. As with anything involved with math and numbers, it's so easy to make those small mistakes. So this gives us a chance to look back and say, does that look reasonable? We need to find the z-scores for the value of the variable, and then we use the table to determine what area we're trying to find. So see what we mean. We're going to work on this one. Working with the IQ. IQ is basically a classic normal distribution, a classic bell curve. So we measure it on the Stanford revision of the Binet-Simon intelligence scale. It's normally distributed with a mean of 100 and a standard deviation of 16. So we're going to determine what percentage of the people who have an IQ between 105 and 125. So first step, let's sketch the curve. Again, if you're doing more of this, you can always go to Desmos and explore if you go to the keyboard and under functions, you can find distributions, find the normal distribution and play with this a little bit. That's how I made my graphs. But we're going to kind of go down to the standard normal distribution here. We'll do more with using Desmos when we get to doing the lab over this. I know you can hardly wait. Sketch the curve. Mu equals 100, sigma equals 16, and there's our curve. Let's get our pointer up here. Blah, blah, blah. So we shade the region. We're going from 105 to 125. So we shaded this. Again, as I said, we could approximate at this point. We know that it's symmetrical, so this would be half. So it has to be less than half. I would maybe say it's going to be a little more than a quarter. So maybe about, 30, 35, 40, somewhere in there. Get a ballpark figure what you think you're going to get, and that will maybe help you figure out, did you do things right or not? Okay, so now we need to find the z-scores. So again, if you remember your formula for the z-score, let's put that up here quick. I gotta switch this over. So your z is going to be x minus mu over sigma. So we're going to take 105 minus 100 divided by 16 gives you a 0.31. And 125 minus 100 over 16 gives you 1.5625. Take that to about 1.56. And I'm rounding to the nearest hundredth place because that's what I can look up on my table, right? So, looking those up on my table, I get these values. I'm looking at the area between, so I take the difference. And I get 0.3189. So about 32% of the people have an IQ between 105 and 125, which also fit into kind of our approximation. Do that. That's one of the reasons to draw the curve. You don't really need to draw the curve to do that, but it really helps at looking at, does my answer sound reasonable, if we can get some reasonable representation of it. So the empirical rule, we didn't really hit this too much. We kind of skipped over this section earlier in the course, but we're going to hit this again with the standard, with a normal distribution. about 68% of your observations are going to lie within one standard deviation. About 95% will be within two standard deviations, and 99.7% within three standard deviations. And that's that three deviation rule. We say almost all of the data will fall within three standard deviations. This empirical rule says 99.7% within three standard deviations. So we can use this as a ballpark. These aren't exact. As I say, these are approximations to make some of our calculations easier. But to talk about this bell curve, this empirical rule, the grading system we use, giving you an A, B, C, D, F, is based on a bell curve. They're saying if you have a normally distributed population, your grades should be normally distributed. In which case, your mean score, your average score, is a C, and within one standard deviation of that average score is going to be 68% of your grades, and that's where your C values should show up if you're grading on a curve. If you go one more standard deviation, that's 27% are going to be between that 1 and 2 standard deviations. We put half on each side. That's half. So 13.5% are B's, 13.5% are D's. So if you're 2 standard deviations above the mean, within 1 and 2, you are above average. If you're between 1 and 2 below the mean, you're below average. Then that leaves what's left, which is that's 95% of the data here. So 25% or 5%, 2.5 is greater. That's your A's. Those are your exceptional. And 2.5% are more than 2 standard deviations from the mean. That's your F's. That's your failures. That's the basic idea behind our grading scale that we use. It's not the popular view. The most people think that our distribution should be left skewed. We should have a whole bunch up here, a lot of A's and B's, and then we come off a bunch of C's, a few D's, and almost no F's. But that's not kind of what that means. It puts a different spin on things, doesn't it? Okay, so other ways we use this. What if I want to find the 75th percentile for IQs? Well, I need 75%, so I look up 0.75 on the table to find the z-score. The z-score is going to be between 0.67 and 0.68, so we'll call it 0.675. You have to look up your own table. I didn't copy the tables in all of these. You have your table. You can do that. Hopefully you have your book with you, right? Convert the IQ. So this is just another form of that z equals x minus mu over sigma. We solve that for x. This is how to find your actual IQ score from the fact that we know, well, mu is 100, sigma is 16, and that's 110.8. 75th percentile for IQs is 110.8. So 75% of people have an IQ below that. 25% have an IQ above 110.8. So that's just a few examples of using that standard normal distribution, converting back and forth between your normal scores and your z-scores, so that we can use that distribution, using that table to look up and do those problems. So, have at it.